Okay, so let us solve one more problem on conservation of momentum and energy. So this problem, as usual, the misconception here is that, okay, let me read this problem, then I will explain it. A rocket is fired vertically. You have a rocket, this is fired vertically. Which one of the following describes what happens to its total momentum and kinetic energy, total kinetic energy? Remember, we're talking about total momentum and total kinetic energy as a result of explosion. Now it's going with some velocity, it goes to the highest point here. And when it goes to highest point, it explodes. What do you mean by exploding? That means this whole thing is breaking up into two parts. Okay, this is similar to that of the internal energy problem that we saw in the previous two lectures back. So here what happens is one of the pieces goes in this direction. The other pieces definitely goes in this direction. That's what you can see. Okay. Let me call this mass as M, this mass as capital M. Some terminology we use it. Now what happens there? Now as we know, when there is a explosion happens, then definitely the total momentum is conserved. Okay. Total momentum is conserved. What do you mean by that? Total momentum is conserved means when it reached the topmost point, it did not have any speed, right? So therefore, it did not have any speed, and total momentum. So total momentum at the maximum point was equal to 0, which is also equal to m into v1 plus capital M into v2, and v1 is this one, and v2 is this direction. And you see these are oppositely directed ones, and thus I can now say this is mv1 minus mv2. So this momentum would be negative, this momentum would be positive, totaling out to be 0 because both are vectors. Okay, so therefore, total momentum is unchanged at the topmost point. Next, let us look at the next one. Total kinetic energy. Now, kinetic energy of this particle would be half m v1 square. Kinetic energy of this one would be half m v2 square. Okay, so as a result of this, when the particle was at the topmost point from the ground, its velocity was 0. But the moment that explosion takes place, its kinetic energy, its total kinetic energy is seen to be equal to half mv1 square plus half mv2 square. Now, one more thing that you have to notice here is that here momentum was conserved because momentum is a vector quantity. Here it's a scalar quantity. So as a result of this, the kinetic energy increases. So therefore, this option is incorrect. Most of the students, what they think is, they think that it went up. So momentum increased because this velocity is larger, this velocity is larger. They will add up these two, mv1 plus mv2, and they think anyway, momentum has increased. So therefore, they will always write C as the right option. Okay, this is a misconception. But what actually happens is, wherever it is, when the particle goes upwards, when there is no external force being added, then in that case, you observe that the momentum remains unchanged while the kinetic energy changes. Kinetic energy increases. So the correct answer here is that momentum is unchanged and kinetic energy is increasing. So it is the option here. Okay, I hope you have understood this concept. So thank you friends for watching. Next class we will see some more problems. Thank you. If you like this video, do like, share, comment, and subscribe to my channel for further updates.